cyber security standards, and so I was given to understand that it will be the college students. It's in the college environment, so college students will be the primary audience. So my target audience was more directed towards the growing population of developers of mobile applications, of web applications, of any kind of applications. The rest of you might find it a little bit boring. I apologize for that. So what we are going to talk about is how do we build applications on mobile platform that are secure. Already in the morning we were given to understand that security comes from the user. It is also imperative that the developers think in terms of security. Developers think in terms of implementing the secure practices. And whatever I am going to tell is a very, very generic practice. It is not something that can be blindly taken into, because everything depends on the context in which we are working. But why did I choose this specifically was primary because the platform, mobility as a platform itself is so ubiquitous that everyone, even when we go to a dinner with say 3 or 4 of our friends, in the dinner table, instead of talking to each other, we talk to our mobiles. So this is the actual landscape. Dinner conversations were fun, but now this is how the status updates happen in Facebook. It's kind of hilarious, but that's the hard reality. So what is it that we need to make sure as a developer to protect our applications? But before even going into the protection aspect of it, you all need to know what are the actual vectors. I'm sorry, the display is not that great. Maybe the color that I choose was not that good. Anyway, see, there are 3 primary targets, target attack areas in a mobile device. One is the device itself. So the first thing that you are not supposed to trust is your mobile device. Second, of course, is the network, because that is open and everything is transferred in clear text. And of course, the third is the server where the mobile applications data repository resides. So these 3 areas form the primary attack vector for any malicious user to break into your application and device. The presentation that I am generally taking now is usually an 8-hour session, because it usually also has a hands-on session, but now I know that it's not going to be more than 30 minutes. The only thing I request is just give me a warning 5 minutes before. I will try to close it as a... See? I am also depending on mobile devices for everything. So the attack surfaces device, what kind of problems are typically coming out on a device-based system? Most importantly, it is a browser-based. Most of the actions that you look at on a device is either browser-based or based on the native applications, or even the system-provided applications which comes along with the operating system. So these are the different types of browser-based. Just for want of time, I'm just skipping each of these. Anybody can access this presentation online. The second one is the phone-based or the SMS-based, where you have smishing and RF attacks. All these are based on your actual phone communication protocol itself. We also have application-based, where most of the mobile applications fail to take security as one of their key requirements and start developing applications on those. The most critical, or the one that I am actually targeting here, is the application-based, because most of us are developers, and hence that is the first target point for us to start our practice. And of course, we have the OS-based, where most of these devices you get in the market which are even compromised. You have rooted system, you have jailbroken systems, where the security of that device is basically broken and it's left open, and anybody and everybody has access to any environment or any operating system modules within that. The other one is the network based. This network based, you have lot of options. The previous speakers also spoke about network based attacks. You have Wi-Fi based attacks, you have packet sniffers, you have man in the middle attacks, SSL strips. These are all typical network based attacks where your DNS could be poisoned. I think somebody in the morning also mentioned about this. SSL certificates being faked, where the CA is not actually authenticating, but it gives you a feeling that it is authenticated. And sessions can be hijacked. Even in a HTTPS mode, sessions can still be hijacked. And the third mode is the data center. This is where the applications reside. They are supposed to be the most secured environment, both physically as well as you have a lot of perimeter based controls to ensure that nothing gets interrupted in between, but they do have their own list of vulnerabilities which a developer or a hacker typically can use. So this is the first place where a script critic starts to play, because that is the topmost layer which is easier to attack. And most of the developers actually forget security in this area. So within the data center, you have two different areas where it can be exploited. One is the web server or the app server itself that can be compromised. And you have the database that also can be essentially compromised. The database is something which is the key target in most of the cases, because the information that is persisted in the environment is what people are looking out for. So your credit card information or your personally identifiable information, or PII as it's called, those are all something that can be extracted from the database if the database is not appropriately configured or secured. So that was I know that was at too fast a pace. But there are certain ideas that you as a developer can think of before you start writing your application. Like I said, most of these, they are only best practices. They are very generic. And they are not something like that is carved on stone, because each of these practices depends on the application that you are trying to build. So for example, if you are building a wallet, obviously you are going to store a sensitive data, but you'll have to make sure that that sensitive data is protected. But if you are doing an application for, say, something like eBay or Quicker or anybody of that sort, you don't have any business to store any of those sensitive data, because they are just supposed to be acting as an interface to the shopping store. So protecting that sensitive data, the best way is not to even store that data. So any sensitive data, see, there is a different idea behind the sensitive data itself. There is a separate classification for the data that you can or cannot store. So based on the classification of the data that you are looking at, you will have to protect or ignore the data. So the first practice when you are talking about data security is to avoid storing the sensitive data. And almost all the applications obviously cache data. So for example, if you go to Google and you type anything on the Google search bar, there is a look forward, and it also shows you the history of whatever you have searched before. That is because the browser itself caches this data. The reason for caching is performance, obviously. The expectation is that you are going to search on certain things, and all the connected search context based on that is what the browser or the application typically brings up. And based on this, it will start identifying it will start rather managing what you kind of have been searching on for all these days. So it will start tracking your interest, it will start tracking your most favorite searches. So that is something that is inherent in any browser. So, but if you are writing an application, you make sure that you are not using any of these cache. So, caching is something which nobody really bothers about in the initial stage, but then it hits them very late, and that time it becomes very dangerous. Yeah, and the easiest way to query any web application is using the query string. Query string is whatever you get on the address bar on the top. That's just after the question mark and the ampersands. So what happens is you just change the parameter in one of those query strings and execute it. It hits the server and comes back with a new result. So this is one of the easiest ways where you can let anybody compromise your application. Of course, there are ways to prevent that. But using query strings as a way or as a means of building your application is a pretty risky thing to work on. And more than that, there are two ways in which a HTTP request can go. It's a get or a post. Get is constrained by the length of the URL, whereas post is typically has a very not much of a restriction. It has restriction. It can support up to 1024 KB of data, but post is also a much more better method than using get as a way of querying your application. And this is contrary to what I usually say, avoid the crash logs. Generally, when an application is built, the first thing that they would typically ask for is the crash log. Yeah, that is essential. But as I said, it has to be taken with a pinch of salt. So crash logs are something which gives you the internal state of the device, along with the data that really caused the crash to happen. So you will have to make sure that if you are writing a very sensitive application, avoiding this crash logs is something which is essential. But if you are writing an application that is not that critical, yes, having crash logs is okay. Yeah. This is more at the server level control as well. Validating the SSL. Most of the applications, they actually don't do this validation properly. That leaves the man in the middle attack a very simple and easier one. And essentially, you'll have to make sure that whenever the certificates are being thrown, the certificates use proper encryption